Hey, what's going on, guys? I hope everybody's having a good Tuesday. In this video, I'm going to show you how to replace the A-star algorithm that we previously added with the Navmesh agent. So right now, these zombies, for example, are chasing me around. Not this guy, he's floating, so I didn't do that. But these zombies are chasing me around using the A-star algorithm. It's pretty good, but there's a lot of stuff that it doesn't cover. And let me just pause this before I die. So you can see the grid here. Let me just turn it on in here. So the way that it works is a bunch of rays get cast down and they make a square box. This is a really quick explanation, but there's a bunch of rays that get cast down, and if they hit something, then they get assigned like a walkable status. And the red areas they can't walk, and the areas that are close to objects are a lighter shade of white. I don't know if you can see that, but it makes it so that the zombies will walk a little bit further around the objects if they can. So like you can see like around this edge, this is a little bit darker. So if those zombies walking like this, they might actually go around this way instead of going like and cutting the corner and just like going like directly towards you. So it's pretty good, but there's a lot of problems. So for example, you can see that these rocks have a red area, which means they can't walk here on an area that is kind of, they should be able to walk there, right? Like there's enough room there where the zombie could fit. And so the only real way to fix this is if you go into the grid and you lower the node radius, which makes more squares. It's more accurate, but it can take longer for it to draw because it has to cast so many rays, and it's kind of not good performance wise. So there you have cases like this, like for example, if you move one of these tiles probably will be moving in the game at some point because that'll make it more fun. I added jumping recently, so you can jump out here. Let me just show you. So you can jump now. So let me just turn get those off. I'm probably gonna die, but you can jump now, which is pretty cool. And it would be cool if these little squares moved around so that you have to try to stay on top of them. But you can see that when we move this square, because the A-star algorithm is only calculated when you walk into the room, it doesn't update this automatically. And if you want this to update in real time, like if this continuously moves, and you want this to update in real time, then you have to redraw the entire grid, or you have to do a calculation to determine. You could attach a script to the object that's moving that does a calculation inside of the grid and just redoes that area. Or you could also do it in like a radius around the object that gets moved. That's a lot of work. I'm not going to do that. I believe there's an A-star algorithm on the shop, like the Unity asset store. That's really good. That does that automatically, and it's probably better than the Navmesh. I don't know, but I'm just going to use the Navmesh because that's not free. So I'm just going to be doing free things in this series. I'm not going to be doing anything that costs money. All right. So the first thing you need to do to use the Navmesh is you need to install it. So if you haven't installed it already, if you go to Window and then you go to the Package Manager, you can type in Nav at the top, and there should be an option for AI navigation. So if you click on that, if you haven't installed it, there'll be a button here for install, and you can just click that and it will install it. And you have to do that before you add it. Obviously. So here I am in the main room. Now, this is just a room I'm working on that doesn't match the walls. I'm just messing around with like how some of the rooms look and stuff like that. And so what we want to do is you'll click on the floor and make sure it has a box collider on it. Now, inside of my floor, I have a lot of objects, right? And the way the Navmesh works is by default, it doesn't use the colliders. It uses the actual geometry to create the surface, right? So let's right click here and or click add component, and we'll add a Navmesh surface. So if you click bake by default, you can see that it's only baked the areas inside of these little tiles or whatever, right? And this is based on the minimum region area. So you can see these small little rocks, and you can actually make these bake if you want to, if you just lower the region size to be smaller than the object. So if you click bake, you can see that will add this on top of like all of those. So in a case like this, though, we don't actually want to bake all these individual tiles, because what's going to happen is this zombie, when we add the Navmesh agent to him, he's going to be, there's no connections between these tiles, and he's going to be stuck on one of the islands, and he's not going to be able to move because he won't be able to get a path to you. So if he can't get a path, he's just going to stand still. It's going to look stupid. So let's change this back to 2. And what we want to do is we want to bake via the collider rather than all of the individual objects. So what you can do is instead of render meshes here on the right in the settings, you can use physics colliders. And then the other thing you want to do is you can see that on top of the walls, it's baked on top of the walls and on top of like the torches and stuff like that. We don't want to include all of the layers. So inside of the object collection under include layers, you can do nothing and then just change this to floor. And then if you click on your floor on the right in the layer, just change this to floor. So that way it's only going to be baking on the object that you have selected. Make sure you don't change the children because we don't want to bake the children at all. We just want to, I mean, it's not going to matter, but we're not going to be baking the children. We're only going to be baking the box collider, which should cover everything. So if you run this again, you can see that it's a pure blue area and the zombie will be able to walk all around here. Now, the reason that it's not on top of these little tiles is that the box collider is actually slightly below the floor. That's just the way it turned out, but the whole area will be walkable. These tiles, they don't have box colliders on them, so they won't stop the zombie from walking around. So that's great. The other thing you can do is if you have a room that has gaps, we'll get to it later, but if you have a room that has gaps in between the tiles, you can override the voxel size. The higher this number is, the bigger the voxels are. So voxels are like little square boxes that we're using to, it's very similar to like the A-star algorithm where we're casting array or whatever, but it's just a voxel instead. And this is the radius of how big each of the increments of where the agent can move. So it will make it so that more of the area will end up getting filled if you make this number larger. It also goes faster as well. So we'll get to that later. We're not going to do that right now. Also changing the tile size, or sorry, the region size can also fix gaps. Some of my other rooms have very small cracks in between the bricks, and I don't want those to be not walkable, but I don't want the entire floor to be walkable. And if you do it the other way, then you're going to have to put like box gliders or something else around the areas you don't want it to walk. So let's go into the zombie. So I've just dragged a zombie prefab from a previous video that we've done together into the main area right now. This would usually go in the enemies folder. So I haven't really tested this, so we're going to see what happens. But on the right, you could click add component and type in Navmesh agent. And so this is how you'll follow your character around. So then we're going to add another component, which is going to be a script. Let's just create a new script. So a new C# script, and we'll call this enemy nav mesh. And so this zombie right now for this video, we're not going to factor in the health or anything like that. That's all stuff that we'll probably do in a later video. Otherwise, this video is going to be too long. So drag the enemy nav mesh script onto your robot, like your enemy robot. And then if you double click on it, you can open it. If you don't have the robot, like if you're not following my game series for some reason, you're watching this video, you could just put this on a cube. So you could put a cube into the scene and that's fine too. It doesn't really matter. So inside of this, what we want to do is we want to set the target to be the character. So we need a couple things in here. We need the Navmesh agent and we need the target. So we're going to do public Navmesh agent NMA and public transform target. Okay, and you're going to have to use Unity Engine AI for the Navmesh agent to appear. So then if we save this, we can go back to the game and we just need to drag the things into the slots. So if you click on the robot on the right, you have these two options now. So one of them is the Navmesh agent, which the zombie is a part of. And then the target, we want that to be the player. So you could put your player here, or you could put, like, if you're not following my game, you could put another object into the scene. It could be another cube or a sphere or something. And then when you move it around, it will chase it or whatever. So yeah, so then all you have to do is in the update, you can do nma.set destination, and then the destination could be the target. Target.position, because it has to be a vector 3. So you should only do this. So you shouldn't do this every frame because so for example, my computer, my monitor is running at 360 FPS. So if you do this every frame, it will probably cause lag, and you don't need to update the position every frame. Your character will only move very small increments usually per frame. So you want to do this based on the distance that the zombie is from the character, or you could do it in an increment of time. So like after a certain period of time passes, it updates the target location. We're not going to do that right now. My computer's really good, so this will probably be fine. It's only one unit, but we will be adding some type of like performance enhancement so that it's not doing this every single frame. And you could also just use fixed update for this if you want to, and that will make it happen. So fixed update only happens, I think, 50 or 60 times per second, whereas update will just do as many frames as you're getting. So that will make it slightly better. It's again, it's not ideal, but it's good for right now. So let's see what happens. Okay, so you can see that the zombie is chasing the character and it's going super duper slow. So the best way to update the settings is to do this while you're running it. So yeah, so these are the settings that I found that work best. So I set the speed pretty high. Mine's set at 40, but that's because I have a gravity offset in my project settings of negative 110. So if you go into your game settings, like under edit preferences, um, not preferences, edit project settings, there's a physics area, and I've set mine to negative 110. If you haven't done this, then you need to set your speed to much lower because it will be way too fast at 40. So, but these are the ratios. So like if you change it down to 4, you could just take off a 0 from the end, so 200 and then 30, and then you could play with these settings and do whatever you want to. So this seems to be pretty good for me. Um, there's a lot of other things that kind of go into this. So let's take another look. Let's take a look at it, one of the other rooms. So I have this other room that I made, and I've already applied the nav mesh to it, but I want to show you. So let me get rid of the start room, and I'll enable this room so I can show you. So let's turn on the gizmos. So if you have a room like this that has gaps between the floor, then you need to change the settings so that it only targets the box colliders again, because remember that the box colliders are there's a bunch of gaps here, so we want to target the box colliders instead of the gaps. So each of these cubes inside of the room, you can see has a box collider around it, and we want to target the physics colliders rather than that. So all of these need to have the floor tagging for them to be considered. And if you have a huge gap in the floor like this, what you can do is inside of the scene view, you could click on one of these that already exist, and you could edit the box collider and just move it so that it covers the hole, so that when it generates the nav mesh, it will fill in that hole. So let me just show you that. So if we bake this, you can see that now that hole is filled and the zombie will be able to walk through it. So that's how you can deal with that. If you try to bake it by using just the render meshes, you won't be able to fix this. There's too many holes in the mesh, and because of the way that it works, it's just not going to ever work. Even if you change the voxel size to something massive, it's not going to work. So we'll just put this back to physics colliders and bake it again. And the other thing you need to know is that if you have any obstacles in your room that you don't want the nav mesh to walk through, you have to make them nav mesh obstacles. So if you click on it, you can click add component and nav mesh obstacle. This will block the zombie from walking through this. Okay. And if you block this area and there's like blocks here as well, your nav mesh might get stuck. So it's important that you fill in all those gaps as well. So let's go ahead and add nav mesh obstacles to all of these. And then we're just going to quickly fix the colliders a little bit so that they cover everything. And this is one of the benefits of the A-star algorithm, because you don't have to do this with the A-star algorithm. The A-star algorithm will just, it's based on like square boxes as the radius or whatever. We could just do this probably, and just like that. These colliders can overlap as well. So yeah, we'll do that. Just make it a little bit bigger. Maybe do that. I don't see the dot here. Oh, there it is. Okay. Okay, so let's click the floor and we'll click bake again. Okay, so let's do this. Make this bigger like that. Cool. And then this one can be bigger like that. And then we'll You can spend more time doing this perfectly. I'm just doing this quickly for this video. So then this one we'll just do like that. And then we could probably just drag it up here too. And then here we can do this and this maybe. And then we'll take the tiled room, we'll bake it. Okay, so this is probably good enough. So then what we want to do is I'm going to save my project for right now. And then I'm going to press play. And then I'm just going to, because the way my game works, it will enable the start room. So I'm going to have to disable the start room and turn off the, oh geez, okay. So let's just turn off the start room here on the left. And we've got the A-star grid showing over top of everything. Let's just turn off gizmos in general, and we'll just see what it looks like without the gizmos, because the A-star grid generates at runtime, and we're going to be getting rid of that altogether. I'm going to be eviscerating that from the project. So yeah, so if we run this now, you can see that the zombie perfectly walks like around the areas that he's allowed to. Yeah, so the Navmesh agent, again, it also does a better job avoiding, oh, I pushed him back pretty far there. It does a better job avoiding each other as well. So if you press Control D and duplicate the robot and you move this robot a little bit over, they should do a good job at avoiding themselves. So like they can walk around each other. They won't actually like try to crash into each other. And again, this depends on their radius as well. So if you turn up the radius, they should stay further apart. So let's do that. So let's turn up both of their radiuses to like that. And let's just move one of them away from the other one so they're not overlapping. And yeah. So you can see now they stay that distance apart. Oh shit, I went through the door. I'm not supposed to be in this room yet, so going through the door brought me into the same room I was already in because my map algorithm doesn't expect me to teleport between rooms. So, oh, that's not good. Let's just not have oh, I didn't put an obstacle. Did I not put an obstacle? Navmesh obstacle. So these are probably not overlapping, and it thinks it can go between the gap between the two of them. So I wonder if I change the size of the Y. Oh, it's not matching the box collider at all. That's the problem, because the Navmesh obstacle is not taking up. So that square box around it is the box collider. It's not the obstacle. So we need to do like this. And then we need to copy this, put it onto this other rock that he's stuck onto. And then we need to carve them, don't we? So these need to be carved. And then this one can also be carved. It's okay. So now that we've carved, now he'll walk around it. So, okay. So you got to do that ahead of time. I made the nav mesh obstacle the wrong size. So we need to copy these settings. Hang on. Let me just copy this and put it onto all the rocks. Hang on. This one doesn't even have it. Let me just paste the whole component as new. And then paste component values. Okay, so if we run this again, so you can see that it's carved out now. So they'll actually walk around. Let me get rid of the gizmos. Actually, let's keep them. So that was the problem. And that was why they got stuck, is because I didn't click the carve option. I think also carve is for like if you have an obstacle that's going to be moving. The only reason we had to do that is because we baked the mesh already, but because we added these obstacles while the game was running already, it didn't actually cut it out of the mesh because we have to bake it with the obstacles already there. But by adding carve, it makes it so that if you move the object around, it will automatically update the nav mesh to accommodate where it is. So like if you do this, for example, you can see that it's cutting out areas of the nav mesh so that the zombie can walk. So if this, like, let's say this is one of the spikes from one of the spike rooms and it's moving back and forth and there's enemies in the same room, you want it to go around it where it currently is. And I think these settings affected as well. So the time to stationary and the move threshold affected as well, like how long it takes to update and stuff like that. So that's pretty much it for the day. This is what we're going to be replacing the A star algorithm with. I think it's a lot easier, even though like I mean, I had a couple difficulties, but it's way, way simpler than the A-star algorithm. The A-star algorithm is just it's pretty complicated, and I probably should have just made the series with this to begin with. So I hope you guys enjoyed the video. If you did, make sure you like the video and subscribe to the channel, and I'll talk to you guys later.